So we're here with the rdot. Hello, so who are you?
Hello, my name is Felix Carlson with rdot. I'm the CEO.
And right here you have a smart poster.
Yeah.
And you're doing, what are you doing? Special display technology?
Yeah, so we're making a printed electrochromic display. It's based on polymers. We have a roll-to-roll screen printing process.
So is everything your display?
Yes, so this is the actual active area of the display. So this is a simple demonstrator of how you can indicate, for instance, carbon dioxide levels in the poster.
Is it high right here?
Yeah, it's high right now. It's really high right now.
Because it's...
I guess maybe I'm too close breathing. I don't know.
Yeah. And here's also showing your display.
Yeah, exactly. So here we have a simple clicker with a PCB. So here it is.
Oh, there we go. Gotcha. Okay.
So this is a simple counter.
Yeah, but then you can make them in various colors. Like we have this green.
So what's special about your display?
Red.
What is this electrochromic technology you have?
So what is special with our display is the ultra low cost thanks to the manufacturing process.
We also have.
It's also very energy efficient. So I can show, if you have a battery, I can show switching.
High reflective red and green to dark.
Alright, so this is the off state.
Gotcha. And also
Touching the electrodes. This is a 3-volt battery. Turning it on. So this is approximately 100 millisecond switch. And it will retain this image up to an hour approximately.
Yeah, exactly.
And as you can see, it's very bendable. It's on a plastic substrate, somewhere around 120 microns thick.
So it retains for an hour?
Yeah, somewhere
So it's
around
not
an hour.
bistable?
It's not fully bistable. It's what we say semi-bistable.
So how does it work?
Around 100.
It's a conductive polymer-based electrochromic. So it's ions flowing in and out of the polymers, changing the optical state.
So is this going to be great for IoT?
Yeah.
What does this show?
This show, it's actually a watch application.
So you have a watch?
Yeah, I have a watch. It's a little bit.
Nice. So what does this do? This watch? Does it show the real time?
So, yeah, it shows the real time. So what we're showing here is actually that we can assemble the electronics straight on the display substrate. So this is the watch. So we have all the electronics on the display. So we call it system on display.
What's the electronics you have there?
That's some simple MCU.
Some ST something or?
This is let's see here.
So it has a clock
running
on a microcontroller?
Yeah, exactly. We also have a crystal there to make it more accurate.
Is this printed electronics around it?
It's everything is printed except for the conventional chips.
And how about the battery?
The battery is on top of this, so we don't see a battery right now. So we add the battery on top.
Sure. Yeah.
Nice. And so your watch, can we see it again?
Yeah, sure.
So it shows the time. What else?
Yeah, we have 3 indicators right here. So this is what we say like general purpose indicators.
What? General what?
General purpose indicators. So it can be, for instance, if you have any missed calls, if you have any, you name it, you have schedule a meeting, something like that.
It could be like a smartwatch.
Yeah, it's a very like low-end smartwatch. But what we actually showing is this system on display.
Do you have something like this in the market?
We don't have anything on the market right now. We're a little bit pre-production stage.
Where are you based?
We're based in Sweden.
And how soon?
How soon?
How soon is all this on the market?
Yes, so we do have a large-scale manufacturing partner, so we can reach the market. We can go to millions of units, probably within 6 months.
So what if somebody makes an order?
Yeah.
And here you're showing the smartwatch too?
Light reflective indicator.
So this is a smartwatch that's fully printed.
Yeah. So I just need to clarify.
It's a little bit like magic, but it's not.
don't need actual
Is it like a segmented display?
It is a segmented display. So we don't sell the smartwatch. We sell the display.
Just because of the
So, but you have different. Is it all segmented?
Yeah, it is. And I can also show that we have some colors. So we can switch the colors here. So this is the bright red. This is bright red.
So here's something that went
Sure.
And
So
let's
here's
see here.
can you go from clear to opaque?
Switching to black.
clear.
All right.
Fully transparent.
The whole screen switched, right?
Yes, the entire screen.
Maybe fully
And
transparent.
I can go back to.
Can you go from some level of transparency
Can go back to bright.
to some kind of opaque?
Nice. It's really bright.
Yeah. So we can do this in really large areas.
Not at the moment.
So-
Here we have some bigger straps.
We are working on it.
Okay.
And they're also
I'd be
moldable.
very interested to hear if you can do
We can mold them. So if you have a device
So
with a
unfortunately, I
certain
don't.
bend
They
radius,
just change jobs.
we can
Yeah.
pre-mold them
Yeah.
if
But
needed.
this is
Perfect.
And are you able to
And
do like
I can take
architecture?
a picture
Huge?
of-
Yeah, definitely. So that's actually the first purpose why we made these tiles. So we can make these tiles and we can connect them together and we can make a huge display.
But what's
Then
the
we can
price?
see how far.
It's a very low cost.
having,
It
like,
really depends on the
Yes,
application and what kind of features you want.
Like, are we talking cents?
We're talking cents. Yeah.
Cents.
Per square centimeter.
Nice. And do you have more over here? What is this demo here?
Yep. So this is kind of a ball pen blue. This is a blue. Switching to. Oops. I think we have some connectivity issues. It's not connecting properly, but it's switching to white.
Okay. It should switch faster? Or?
Yeah, it should switch faster.
So how does it work to switch? Is it like some current goes in there and says, hey, switch now? Or?
Yeah, you apply a voltage and it's ions flowing in and out of the electrochromic material, and that will change the optical performance of the polymer.
So how does this compare with e-ink, for example?
So we are targeting a more low-end market compared to e-ink. So we have a cost advantage in relation to e-ink. Also for certain applications we are lower power than e-ink. If you switch it more frequent than for instance 5 to 10 times per day, we consume less energy per the same area
So it will
compared to
remain
e-ink.
in this state.
Any chance you can do
And you need to,
active
like,
metrics?
put
So what's it called? A
small
fully,
pulse, maybe.
what's it called? A fuel display?
Yeah, so we haven't done that yet actually.
What would you need to do to make it happen?
Yeah, we need to pixelize it. So the limitation right now is in terms of resolution. Right now we're making a little bit, segmented. It's not high resolution displays. So we're targeting more low-end markets with this one.
Do you have any questions?
Is this shelf labels? What
Yes,
market?
they can be used for shelf labels. They can also be used for packaging, for instance, IoT and sensor applications. So more or less wherever you need a very, very low cost, very, very low power solution, this is the perfect fit.
Nice.
Oh, no,
So
this one
you from Sweden?
We're from Sweden.
And what's next?
Well, no,
What's
we don't
next?
have that.
I think we're kind of still searching for the first perfect fit to the market, the first really, really big application. We'll have a lot of custom designs projects with customers. The next step is to reach large-scale manufacturing.
And it could probably